Okay, so welcome everybody. So my name is Corey Dow, Technical Marketing Engineer with HP Aruba Networking in the switching group. So today we're going to cover AOS-CX 10.13 updates for the reserved GBP tag for internet traffic, and as we'll come to see also intranet traffic as well. Okay, so this is our typical agenda. I'm not really going to cover this since we have the same agenda for all of our presentations. We will have a demo at the end, and hopefully that'll highlight everything that's being discussed in the presentation. Okay, so just as an overview of what GBP is, so it's also known as virtual network-based tunneling. VNBT, or also known as a group policy option. We hear these terms used interchangeably for the future. And what it does, it establishes a mechanism for role-based access control within an EVPN VXLAN fabric. So policy IDs are mapped to user devices or roles, as you can kind of see here in the bottom of the screen for APs and cameras, et cetera. And these policy IDs are input into the EVPN VXLAN headers that are transported across the network. So the egress VTEPs have configured group-based policies that determine whether or not the source role is authorized to communicate with the destination role. So by default, intra-role communication is permitted, but inter-role communication is denied by default. Local user roles are assigned to each of the authenticated devices that have associated group-based policies. And macro or micro segmentation scenarios are supported where either inter-VNI or intra-VNI segmentation for the roles. And part of the journey along the way, again, because this is review, Aruba Central Net Conductor can also orchestrate and automate the provisioning of the roles and policy creation. So we first introduced GBP in AOS-CX 10.08 for single fabric in stub VTEPs, and I just show some of the YouTube collateral that's available out there for review. And then with 10.11, we extended to multi-fabric EVPN VXLAN. And now also, well, part of the journey as well. So orchestration of fabrics and roles were supported with Aruba Central Net Conductor 257. So that's kind of where we are prior to 10.13. And so what's new with AOS-CX release 10.13? So what was missing was the ability to tag traffic at the border VTEP arriving from external networks, either the internet or internet. So as you can see on the right-hand side here, we've got a border VTEP here, core 1 and core 2. So most of the segmentation is east-west traffic going across the fabric. But say we have traffic destinations coming in from either the internet or internet that don't have GBP associations with them. You can't really affect policy decisions at the border unless you have a mechanism to do that, to tag that traffic. And we'll see what that looks like in a moment. So GBP is applied at the ingress VTEP post-authentication with MAC or A2NX authentication. But as I mentioned, traffic arriving from external networks are not initially tagged with any group policy IDs. And so as a review as well. So this is what it looks like. The group policy ID is put within the VXLAN header that you see here. And then that gets mapped to a specific role on the switch itself. So to support policy enforcement with north-south and south-to-north traffic flows, in addition to east-west traffic, we needed to provide this capability. So now with 10.13, what we have is reserved group-based policy ID tags that were introduced for tagging the internet traffic with a policy ID of 3, the internet traffic with a policy ID of 4, and the ISL for VSX deployments with a tag of 5. And so with the 8360 V1 or V2 core border VTEPs, we also now apply policies to map these non-GBP tag traffic with the GBP reserved roles for either internet or intranet. And so policy enforcement still occurs on the egress VTEPs as they always have for east-west traffic, but now also for the border VTEPs with role-based access lists with AOS-CX 10.13. So as the traffic is going north-south, the border can affect traffic filtering decisions to decide if they're going to allow that traffic to go forward or not. So for the platform feature support, so what we've added, so this is a review also with 10.12. So we have 8325 in the 10K, we added support for GBP tag relay. So this is relay only where you have that VTEP needs to be able to transport the GBP tag, but not affect policy enforcement decisions. So this is what we added with 10.12, and that mirrors the support that we had previously with the 8360. And so now, as you see as well in green here, so we have the GBP reserved internet, intranet, and ISL roles that apply to these platforms in green here that have been added. And then also exclusively for the 8360 V1 and V2 platforms, we now have the GBP ACL role access lists in addition to the mapping with object group lists here. So this is only 8360 itself, and it does require the core spine profile be applied, where the default is actually the aggregation leaf profile. And so we'll see what that looks like as we move forward. So the use cases for reserved GBP tags, I kind of mentioned it already. So internet traffic can ingress or egress the border VTEP with different encapsulations, VXLAN third party, MPLS, et cetera, that may or may not have GBP policy associations. The internet traffic to and from these fabrics can also exit and enter the border VTEP. So there's nothing like internet VRF on the border VTEPs. In most of our deployments, the internet RIB is hosted on the WAN edge box, and the internet VRFs have a footprint only on the WAN edge box, not on the border VTEP. So as a result, enterprise VRFs are extended up to the WAN edge. So therefore, both the internet and the interfabric traffic enters and exits the border on the enterprise VRFs. So we solve that problem on the border VTEPs by associating the GBP roles, either the intranet or intranet with subnets where we want segmentation. And what this provides the user is partial internet traffic suppression as well, where there are cases where traffic to and from some websites are to be allowed and the rest of the internet traffic needs to be denied. So as an example here, I've got guest traffic to hpe.com and arubanetworks.com are allowed, but all other traffic is denied. And so an additional use case is forwarding over the VSX ISL, the border VSX connected to the WAN edge, where you have a link loss between the VSX members and the WAN edge. So in that case, there's a link loss there. The traffic can get redirected through the ISL, and we use the ISL GBP tag for tagging that traffic. So onto the details. So for traffic classes for GBP MAC, IPv4, and IPv6 base classes, they can't be configured under classifier or existing port access policies and match criteria. And all the destination roles in the class entries must match conditions. They must be the same role as you see here. So an example, the IoT class needs to have all the same destination roles. So we can't have guest here. This would not be allowed by the CLI. As was the case prior with 10.11, we now support, we also still support single or multi-fabric EVPN VXLAN deployments. The group-based port access policies support the following actions: either drop the packet, and new with 10.13 as well on the 63 and 6400 platforms, we can now reflect, which enables the switch to allow the packet only if the flow is initiated by the client. So, and this will be covered in the reflexive policy TOI session covered by Shobna on Thursday. Group-based port access policies, they're associated and applied via local user roles. Downloadable user roles are not supported. And as I mentioned, these are just the new tags that are introduced. If the tags are already in use with existing roles, they can be remapped if they're currently in use. And so new, as I mentioned as well, so the intranet role to object group mapping, you'll see this will be more clear as we cover the configuration. So commands are applicable to the core spine profile only with the 8360 V1 and V2. The object groups contain a list of V4 and V6 prefixes that have the intranet role applied. And a unique object group is required if you have multiple VRFs. So in addition, the GBP role ACLs are introduced, again, with only the core spine profile. And so these are applied at the border VTEPs to perform traffic filtering with role-based policies to north-south traffic arriving from the intranet or internet sources. Okay, so as to configuration, so this is just an overview of the steps to create GBP policy for the internet or internet roles. I missed that. Okay, I should say internet and internet roles. WAN edge border VTEPs. So you need to switch the 8360 v1 v2 profile from the ag leaf profile to the core spine and reboot. Then you would create IPv4 and v6 object groups with matched prefixes for the internet subnets. And the prefixes that you don't include in the internet subnets, object groups, they'll inherit the internet role by default. And we want to map the GBP role internet to those configured object groups. And you create GBP IPv4 v6 role-based ACLs for permitting or denying the traffic. And then you apply the configured ACLs as a global policy. They are not tied to specific interfaces or VLANs just by nature of it being a role-based ACL. And then finally, you enable GBP. And then as to the egress edge or access VTEPs. So as we would normally in prior cases, we configure the GBP MAC IPv4 v6 classes with match actions for the source and destination roles and protocols. New source roles for intranet, and ISL are reserved starting with 10.13. As I mentioned before, all the entries in the GBP class need to have the same destination roles. And I already mentioned this, so I won't call that out. And then you need to create port access GBP policies that include those configured classes. And then you associate those port access roles with the created GBP policies and then enable GBP. So we'll go into these in a little bit more detail as we move forward. So this slide is just showing you the new group policy ID mappings that are present with 10.13. So you can see on the 8360 v1 and v2, we have the internet role mapped to group policy ID 3, intranet to 4, and ISL to 5. And then on the access edge VTEPs, you can see the GBP roles there for internet and intranet. So moving on with the further configuration at the WAN border VTEPs. So you want to configure the 8360 v1 v2 profile from ag leaf to core spine and reboot. And this is where we create our v4 and v6 object groups with matched prefixes for the internet subnets. So all these prefixes should match all of the fabric subnets within the network, both v4 and v6. And then we associate these configured object groups with the intranet role. So this is where we map the role intranet to these object groups that we just created. And again, so any prefixes that come in on the border VTEPs that are not included in these lists will get the internet role applied by default. And then we also create the role-based access list that permits or denies the traffic. As you can see here, we permit IPv4 traffic from the IoT role to the 69110 network, and the same with the v6 equivalent. You apply the configured ACLs as a global policy, as I mentioned, not tied to specific interfaces or VLANs. And then finally, we enable GBP. So moving on to the egress edge access VTEPs, so the platforms that you see here. This is all mostly a review. The only real addition is just that we now have new roles for internet and intranet and the ISL. So we configure our IPv4, v6, and MAC-based classes, as you see here, for a class called IoT. You can see they can all have the same class name as well. So I have class IoT here because what is unique about them is IPv4, v6, and then MAC. So they can all have the same name if you weren't aware of that. And then you create port access GBP policies that include those created GBP classes. As you can see, the 3 classes I have on the left are now included in this port access policy. Then you associate that port access role with these GBP policies, as you can see here. And then finally, you enable GBP. So this is just an equivalent configuration specified through the REST interface, just using some bash commands. If you took these and put them on the switch, these would allow you to create the same configurations that you saw on the prior screens. And then the Swagger interface, these are the URIs that are needed to affect those policy changes. And so for AOS-CX configuration comparisons, there really isn't much in the way of competitive differences. Like so, as an example, the next slide will show you H3C and AOS. We don't have an equivalent object group or role-based ACL that is equivalent in any way to what we're doing with CX. So Cisco, the most closest comparison is Cisco DNA Center. So they also use or implement the standard for the group-based policy IDs. It's called different though. It's not group-based policy ID or VNBT. It's called a security group tag. But this, in effect, is the policy ID that you see there. So in these cases, you can see SGT 192s. That's a policy ID that maps to these networks, et cetera. And then the enforcement nodes for Cisco are the policy extended nodes. And these provide the enforcement. And so one thing of note that is a little bit different as well. So we needed to be able to have this capability at the border, but the Cisco equivalent solution with DNA, they have security group firewalls that are both GPO and SGT tag aware. So these devices attach to the WAN edge, so the border manipulations of the roles aren't needed as it is with the case with AOS-CX. So they just have security gateways that affect the policy decision. So that's what's different a little bit about that solution. So as mentioned, no GPO or GBP policies available with H3C or AOS switch. And so for best practices, so you want to configure all the fabric subnets on the border into object groups that are assigned the internet role. Again, otherwise they'll inherit the internet role. Just as a general practice, I typically advise against sequencing policies or classes with entries like 1, 2, 3, 4, 5. It makes troubleshooting more challenging as you can't insert a rule without first resequencing them. And you want to be careful when defining any role wildcards in policies. So the following class provides inter-role communication from any source role, which is not what the customer intended. So this is actually a call that came into us from the field. So in this case, we should have included ARP instead of any protocol, and it's usually better to define which source roles are permitted instead of specifying any role. So in this case, traffic for actually V4 and V6 was leaking through this MAC-based ACL or MAC-based policy that was not intended. Note that the role ACLs configured on the borders have an implicit deny rule for the internet, which is fairly standard for our implementations, but an implicit permit rule for prefixes in the object groups associated with the internet role is there. So this is something I ran into where you can deny traffic if you have prefixes that are included in the object groups. You can still deny traffic, but there's an implicit allow for those subnets because they're considered internal. So if you wanted to deny specific traffic for those intranet subnets, there has to be an explicit rule to match. Okay, so on for troubleshooting. So as with any troubleshooting, you want to make sure that you have a topology diagram, especially for this type of setup, because it can get a little bit complicated to understanding where the roles are applied and where the policies are applied. So you want to have a fairly detailed diagram that shows you where those group-based policies are getting assigned, which roles are getting provisioned, et cetera. And so the recommended troubleshooting flow. So at the border, we want to check that the border configurations are correctly applied. We want to check that the policy hit counts on the border, verify that the traffic classes are matching. You want to verify the internet and or the intranet roles are present in the packets forwarded to the access switches from north to south and south to north. And you want to check policy hit counts on the access switches for GBP policies. And check that denied traffic is actually dropped at the border VTEP. And finally, check resources for TCAM exhaustion as these features do use the TCAM. So just a deeper dive on the troubleshooting steps. So checking that the border GBP configurations are correctly applied. So you want to ensure the ISL intranet and internet roles are present. Again, with 10.13, we've added this, so you should make sure that these are present. Just showing, yeah, so in both cases, just showing that these are present. You want to check that the prefixes are assigned to the internet role via the object group commands that you see here. This is just an example for v4. Check the role ACL configurations with the show commands, verify that those are correct. And moving on, policy hit counts are a great way to see what's going on underneath the hood. So we can see matches for the permitted and denied traffic at the border. So we do the show GBP role access list hit counts command for your role-based ACL, and you should see permits there or denies for the specific traffic that's been configured in the policies. And sometimes it's helpful to clear the counters if you want to see what's going on real time. And this is how you do that. And moving on to some additional troubleshooting steps. So we want to verify the intranet and or the internet roles are present in the packets forwarded to the access switches. So the best way to do that is actually take a packet capture on ports egressing towards the access switches. So in this case, from the border or the core 1 and core 2, we're mirroring both 111 and 112 out to the CPU to take a look at the traffic that's heading down to the access switches. And we want to verify that the correct prefixes have the correct roles assigned here. So as you can see here, it's the group policy ID 4 here is an internet source, well, actually an intranet source that's applied the intranet role. And we want to check the policy hit counts on the access switches for the GBP policies, just like we did at the border. So this is how you would do that. You do just show port access GBP, the policy, and then hit counts. And you should see increments here for intranet in this case, but it's only because this class doesn't have an option here for intranet. But in the demo, you'll see that we will have that as well. So we can see that we're matching, we're incrementing the hit counts for the internet. So we know that the border is doing its job and it's applying the internet tag correctly. And also check that the denied traffic is dropped at the border VTUB. So for an example here, internet destination 1111 is denied at the border, and packet captures at the border A, B, and the border A and B switches can confirm that the traffic doesn't egress out to the WAN edge. And then same as we saw before, check the policy hit counts to verify if you've got a specific deny action for this, then you can count it. Otherwise, you wouldn't really have visibility. As I mentioned here, the traffic will just be silently discarded. And just some additional commands for debug and the event logs for the TCAM, the policy, and also the port access GBP modules. And then the debug buffer commands that are the equivalent for how to take a look at what's going on from a system perspective for GBP. And as this feature does use the TCAM, we want to show resources to verify the entries that are being exhausted, because as we mentioned, the other features do use the TCAM. So this is a good command to verify if for some reason the policy decisions or policy actions aren't taking effect. You're not seeing traffic either permitted or denied as you'd expect. You want to first kind of check the event logs and then as well check the resources. Okay, so on to the demo. Hopefully this ties everything together from what we've been talking about. So the attributes of the demo, this is a multi-fabric shared border here. So we've got an 8360 here at the border. So border leaf 1, border leaf 2, you can see the fabric and the ASN 65535. And then we've also got two other fabrics here, fabric 1 and fabric 2, 65531, 65532. We're just using multi-fabric just to show the different intranet and internet roles and how this can work in a multi-fabric environment. This works just as fine if you have a single fabric environment. Just showcasing that this works in both the single and multi-fabric environments. And so what you'll see in the demo is that we've got traffic going from these sources down here below on the access edge switches assigned to different roles. So we've got two roles here, IoT and signage, from these two subnets, 11.110 and 12.110, going to this destination off of a WAN router or intranet router 1 and the destination 69.112. So there's no GBP on this side of the network, right? So the GBP tag associations get applied via the associations here on the border, and you'll see what that looks like when we go through the demo, and how we also can change or modify the role used in those tags from either internet to intranet based on the object group assignments. And then also the demo will show like the IS6 or the ISL role for the VSX deployments, where we can shut down one of these links and still show that the traffic is working correctly as it's going to cross the border VSX ISL and use that tag link to get across and out from there. So that's pretty much that. So let me close this down and let it play here. Okay, and I've pre-recorded this because you can see there's a lot involved in the configuration. There's a lot of moving pieces, so I thought it was easier to just kind of describe it via the CAN demo. So this is essentially everything you saw in the topology diagram. So we've got border leaf 1 and border leaf 2 here next to it. Router 1 is on the upper right-hand side. And then we've got leaf 1, leaf 2 with the corresponding hosts that are configured in the ports that you see there, 111 and 114. And then the destination is 69112, which is connected to router 1 on the northbound side. So we're just going to take a look at the configurations here. You can see the multi-fabric as we illustrated in the demo, so 65535. And so we'll just kind of go through some of these commands and we'll see what we have configured. So these are just looking at the BGP configuration. So we should see, I think, 65531 and 65532 connecting to EBGP with the 8360 border VTEPs. Okay, and here's where we're just showing that the tunnels are up between the leaf switches and the border VTEPs. And the same thing on the border VTEPs itself. I'm just showing you the 192.168.1.1 shared loopback, which is needed for the VSX deployments. Okay, and again, just like we did on the leaf VTEPs, just showing you that the tunnels are up and operational. And so we just have two VLANs, so VLAN 101 and 102, which is the 11.110 network on leaf 1 and the 12.110 network on leaf 2. And looking at the MAC table, just for the connected hosts that you see directly below. So that signage 1 is connected off port 114, and then port 111 on leaf 1 connecting to the IP cam host. And so this is where showing the profiles that are currently applied. Again, the ag leaf is the default, but for this feature, you need to switch to the core spine profile, and you'll see that we'll do that here in a moment. And again, these features are specific only to the 8360 platform, at least with regards to the 10.13 release. Okay. And as it mentions, once you configure the core spine, you do need to reboot the system. So, and that's what we'll do here. I've sped things up a little bit, so we'll not capture the full reboot, hopefully. Okay, same thing on border leaf 2. And this is after the system has been rebooted, just verifying and showing you that the profile did get changed to the core spine profile. And it's very easy to tell because some of the commands just won't even be available. So the GBP role access list command just won't even be present unless you have that core spine profile applied. And so it's just verifying connectivity. So showing connectivity between the two source host up to the 69112 system that's connected to router 1. And then on this system, I'm just going to leave that traffic going as we apply the configurations for the role-based access control policies. Okay, just pause here for a moment. I'll try to. Yeah, so this is configurations that we have here. So the object group associations here specify the VRF. And again, a unique object group is needed per VRF. So we have multiple VRFs here. You'd have to have the equivalent object groups configured. The prefixes here are 11.110 and 12.110. These will get the intranet role applied by nature of this command here, GBP role intranet object group IP inet and v6 inet. So that's how you tie the intranet role to those prefixes and any other subnets. So like the 69 destination that we have here is going to get the internet role by default because it's not included in any of these object group mappings. And then at the end, this is where we apply the GBP role access list. So let's continue with that. And so we're just going to paste that configuration into border leaf 1 and border leaf 2. And those are the border VSX pair. And you should see at the very bottom left of the screen that the traffic stopped immediately once we applied this policy. And the reason being as well is I don't have any roles associated with those ports on the access side yet. So it's matching on traffic going from those source roles IoT out to the internet, but those clients don't have any associations to the IoT role or the signage roles. So this is where we're going to kind of fake things out a little bit. Just we're gonna configure port authentication here. This is a nice little trick if you have a minimal environment and you don't have a radius server available. You can specify the port access critical role. So if the radius server is not available, it will apply that critical role. So this is just how I'm doing this demo without having actually a radius server in the environment. So this is where we're applying the IoT role to the, and you can see the traffic started functioning right off the bat because we applied the IoT role. This traffic is going up through the border. It's hitting the access control list that we have there that allows that traffic. And then we're doing the same thing on leaf 2 for the connected host here as well. So we're going to give that port the signage role. In the same fashion. Okay, and see where we've applied it. The signage role has been applied. The port is active. And again, just taking a deeper dive look at the GBP policies on the border. And this is where we're going to look at the commands, and we're also going to see the hit counts for the traffic that's egressing the border. And so this is just verifying that those commands were applied correctly. As we know that they were because it started blocking the traffic once we configured it. Okay, and same subnets configured here. So these are the subnets that'll get the intranet role attached to it. And this is where we're looking at our hit counts to verify that we're matching on our traffic classes and our role-based ACLs. And so you can see here our IoT role that's pinging through the border is incrementing the hit counts. And this is just kind of a demo as well. So we're just doing ICMP, which is kind of a good way to just get things started. I mean, to make sure you've got connectivity before you start blocking other things. And so this is where we're looking at hit counts on the access switches as well. And so now you can see where we're matching on the internet role to IoT, and that is incrementing. So we know that everything's working the way we'd expect it. And so this is where we're going to start making some changes. So we're going to go into the object group that's been configured on border leaf 1. And so we're going to add the destination 69110 network to that object group, which should affect a change in that the intranet role should now get applied because that's what maps the intranet role to those specific prefixes. So you'll see that this didn't work the way that I intended it. And this was a mistake in my part that we'll correct just as we move forward with the demo. So it's still matching on internet, which is not what we would have expected. And the main reason, which I'll preview at this point, is when we made the change to the object group setting, we needed to specify the VRF, and I failed to do so. So it's not matching that traffic correctly. So we're just moving on in the demo, and we'll come back to that in a moment. Okay, so this is just showing the configurations to to router 1. And so it's reached through. You can see the route table on the right-hand side too. Let me just pause this for a second. So we see the route table on router 1 shows the 2 different next hops for the 11 and 12 networks. So we've got ECMP paths here going back into the border. Yeah, so what we're going to do is we're going to take down border leaf 1 to see the impact on the route table as well as the traffic flows. So we're booting the border leaf 1 into service OS. And so we didn't really see any traffic loss there, but what we will see is the route table change now, so that we only have border leaf 2 is now where the traffic is flowing through. And can confirm that by looking at the hit counts again. We know that we're incrementing there, so the traffic is going through border leaf 2 and out to router 1 through border leaf 2. And this is where we're going to correct the problem that we saw previously. So now we're going to add 69112 or 110 to the object group, specifying the VRF first, which is what I should have done prior to this, and then just add the rule 30. And this is, again, just showing you how you can impact whether or not the role used is intranet or internet. And so we didn't see any traffic loss there as well. And just showing that we're incrementing our hit counts. Now we're going to look at the access switch to look at the policy. And now you can see intranet there where you see the match of 16 on the hit count. So we see that we've changed that now so that it's matching on or getting the intranet role applied instead of the internet role. And just removing that rule just to get it back to where it was. And so now we'll see the internet role incrementing. And this is just going to show, so from the access switch perspective, or we've got the signage and the IoT roles are not able to communicate with each other. You can see across the access switches. So we're just going to make the change. So this is just review that even in multi-fabric, we can allow those 2 roles to communicate. We just need to change the class commands to allow for that to happen. So we're in the IPv4 class, we're just going to allow signage to IoT and vice versa. And there's a kind of a brief pause there with the traffic flowing, but just give it a few seconds and that'll start flowing again. Okay, and now we see communications flowing between those 2. Whereas previously they were segmented, now we're permitting them. And then the last portion of the demo, I think we're just going to do a shut of an interface going to router 1 so that we can show that the traffic still flows if it needs to go across the VSX ISL. And so that's what we're doing here. We're just shutting down 1136 that leads to router 1 from border leaf 2. And change focus in the lower left there where I've actually changed the destination. So it's no longer pinging the host on leaf 2, it's pinging 69.112. You can see on border leaf 1, we're not seeing any hit counts there because it's still going to border leaf 2 from a tunnel perspective, but then it's switched across out border leaf 1 to get to router 1. And just showing you the route table for how it reaches that network through border leaf 2. And so we've got next hop 59.3.1.1.1. And so that's an L3 next hop connected to border leaf 1, as you'll see here in a moment. Okay, and so that concludes the demo. So let's stop this and have a few more slides left. So let's go back to the presentation. Okay, and just so everybody's aware, so the demo configurations that I have are provided here in this slide. All the configurations that you see there, router 1, core 2, leaf 1, and leaf 2, they're embedded within this slide. So you just double click on these and you can get access to the configuration so you can see how everything is configured in more detail. I just want to thank everybody for attending the session. Hopefully this is helpful. If you have any specific questions on GBP or this role-based access list stuff that's new with 10.13, feel free to contact the distribution list that you see there. Thanks for your time.